Hey guys, welcome. Yeah, so in this video, we're going to define what a circle is, and we're going to come up with the equation of a circle, yeah? Alright, cool. Let's get on with it. So a very formal definition of what a circle is this, which is that it is the locus of points equidistant from a fixed point. Okay. So perhaps the words locus and equidistant obscure the definition. So why don't we make them simpler like this? So a circle is the collection of points equally far from a given point or from a point. Okay, so here's a circle. Since the first definition was a little more sophisticated than we need, we can just keep this one. So here's a point, and the collection of points, infinitely many points at that are equally far from this point are what you see in blue, forming a circle. So that's what a circle is. Yeah? Okay, cool. So then a random point on the circle, which has coordinate xy, could be this, and what we require of it is that the distance from xy to this center point hk be the same as the distance from this center point hk to any other point on the circle. Yeah, so xy could move here, and whatever the distance was from here to here would have to be the same as the distance from here to here, and of course we call that distance r. Yeah, and so r would have to be the distance from this other xy to this center point h comma k. In fact, regardless of where on the circle x comma y is, so whether it's there, or anywhere else on the circle, the distance from h comma k to a point on the circle would have to be r, the radius. Yeah? Okay, so to derive the equation of a circle, we don't need all these points, we just need one of them. So let's retain the guy on the northeast side. Okay, now what we could do is draw the radius, right? And so that is do this, and then complete a right triangle like this. Now, there was nothing special about this randomly chosen point xy over here. It could have been any other point xy on the circle, and we'd still be able to draw this right triangle and do what we're going to do with it, which is the following. Now, let's have a closer look at this right triangle we just drew. You see, this leg of the right triangle right here, that has length y minus k, and the other leg has length x minus h, and such should be the case regardless of where you draw a triangle like this. That is, you could pick any random point xy on the circle and be able to draw a triangle like this, so that one leg of the triangle has length y minus k and the other leg has length x minus h, so long as you call the center point h comma k. So this would be true every single time, which is your triangle would be labeled in this manner. Well, okay, cool. Since this triangle is a right triangle, we can do Pythagorean Theorem. And it is upon doing Pythagorean Theorem that we discover what's called the standard equation of a circle, a key, right here. Yeah? Now, you might need more practice on the standard equation of a circle, so I have at least one additional video with lots of practice on it. But as far as deriving the equation and talking about a circle big picture, we are done here. Yeah? Cool. Alright. I hope you enjoyed this, and it wasn't too robotic or mechanical from me. But yeah, keep watching. Take care.